Search and rescue crews continue to look for survivors in the US state of Kentucky, where record flooding has wiped out entire communities. At least 28 people have died, although the state's governor warned the number could rise.
The first signals of unusual activity came from satellites monitoring the surface of the Appalachian Mountains. What had long been considered one of the most stable and ancient mountain ranges on Earth suddenly showed signs of rapid uplift. So significant that the United States Geological Survey issued a rare red alert. The Appalachian chain, stretching from Alabama to Newfoundland, has always carried the weight of deep geological history. Its rounded peaks and eroded ridges testimony to hundreds of millions of years of weathering. For satellites to detect measurable vertical displacement across such a vast expanse is an event of startling proportions. This was not a matter of minor surface changes or seasonal variations in vegetation. This was the ground itself rising in ways that suggested forces deep beneath the crust were pressing upward. Before we start, smash the like and subscribe buttons for more updates. The issuance of a red alert by the USGS is not done lightly. Such alerts are reserved for events of extraordinary magnitude, whether seismic, volcanic, or tectonic. And they carry the implication that what is happening has the potential to alter lives, landscapes, and entire regions. The Appalachian Mountains, often romanticized as ancient and unchanging, now stood at the center of urgent scientific scrutiny. Geophysicists, seismologists, and atmospheric scientists turned their attention to the anomaly, each trying to understand whether the uplift indicated the reawakening of deep mantle plumes, the flexing of tectonic plates, or some new phenomenon never before recorded. The Appalachians have long been viewed as geologically quiet compared to the fiery tectonic drama of the Pacific Rim or the volcanic ranges of the western United States. They were thought to have passed their prime in Earth's mountain-building cycles, worn down from their former Himalayan scale to their present softened ridges. But now, satellite interferometry revealed something unprecedented: massive sections of bedrock pushing upward by measurable centimeters in mere weeks, a rate far faster than the slow rebound that sometimes follows the melting of ancient glaciers. Such data could not be dismissed as error. Multiple satellite constellations confirmed the findings, showing a pattern of uplift across wide swaths of terrain. The implications of this uplift extend beyond simple geology. For the communities nestled within the Appalachian valleys, towns woven into ridges and hollows, the land rising beneath them could mean altered groundwater flows, shifting fault lines, and changes in stability of the slopes around which life has always been arranged. The Appalachians are a region of rivers and reservoirs, coal seams and forests, and sudden geological changes could disrupt every aspect of this intricate balance. Dams may strain under changing pressures, old mines could destabilize, and new stress fractures might form in places long considered secure. At the same time, scientists began examining whether the uplift was tied to forces deep within Earth's mantle. Some theories proposed that the lithosphere beneath eastern North America might be responding to slow convective currents, a plume of heat or magma pressing upward after eons of dormancy. Others considered whether shifting weight distributions from melting polar ice and the redistribution of water across the globe could have triggered isostatic rebound in regions not previously thought sensitive to such changes. If the latter proved true, then the Appalachian uplift could be part of a larger planetary scale adjustment, Earth's crust flexing under the stresses of a rapidly changing climate. The Red Alert announcement also drew attention to the fact that much of modern infrastructure in the Appalachian region was never designed with tectonic volatility in mind. Unlike California or Alaska, where seismic codes guide construction, the Appalachian Corridor developed with an assumption of stability. Bridges, pipelines, and energy corridors cross valleys and ridges that had not shifted significantly in recorded history. The prospect of uplift forces altering gradients and creating unseen stresses suddenly cast these structures in a new light. A road engineered to follow a ridgeline might one day find that ridge a few meters higher or tilted slightly off its original alignment. From a scientific perspective, the data presented an unparalleled opportunity. The Appalachians, once dismissed as a passive landscape, now offered a laboratory for observing Earth's deep processes in real time. Seismic networks were quickly recalibrated, ground sensors installed, and drilling proposals circulated to probe the deep crust. The question was not only why the uplift was happening, but how far it would go. Would this be a temporary bulge, a passing adjustment in the crust, or the opening chapter in a much longer story of tectonic renewal? There is also the matter of natural resources. The Appalachians have long been rich in minerals, coal, natural gas, and forests. Uplift can alter the accessibility of these resources, shifting deposits closer to the surface or cutting them off beneath new folds of rock. At the same time, it can change the flow of aquifers, with consequences for agriculture and drinking water. Entire river systems could be redirected by sustained geological change, and with them the economies and ecologies that depend upon their courses. Already, hydrologists are modeling how the Tennessee, Ohio, and Susquehanna basins might respond if the mountain chain were to rise even modestly higher. Culturally and psychologically, the idea of the Appalachian Mountains rising again resonates with a sense of myth and awe. For generations, the Appalachians have symbolized endurance, their weathered slopes a backdrop for stories of resilience and heritage. To imagine them shifting in such dramatic fashion unsettles that perception, forcing communities to confront the reality that even the most ancient landscapes are alive with hidden dynamism. Farmers, miners, hikers, and residents alike must reconcile their lives with the knowledge that the very ground beneath them is in motion. Governments and agencies have moved swiftly to interpret the red alert. Emergency preparedness protocols, usually reserved for earthquakes or hurricanes, were reviewed for applicability to a geological uplift event. Local officials have been briefed on the possibility of secondary effects: landslides on steep slopes, shifts in riverbanks, and the sudden appearance of fissures. While no immediate catastrophe was forecast, the acknowledgement that uplift could precede seismic activity introduced an element of unpredictability. The mountains were no longer passive. They were exerting force. In the broader context of Earth's history, the Appalachian uplift is both startling and strangely fitting. This range, born of collisions between continents, shaped by the assembly of Pangaea and reduced by erosion over hundreds of millions of years, may be entering a new chapter. Some geologists speculate that tectonic stresses along the eastern seaboard could be reconfiguring, driven by the slow drift of the North American plate. The uplift might represent the earliest whispers of a renewed cycle of mountain building, what scientists call orogeny. If true, the Appalachians could once again become mountains in the fullest sense, rising to new heights over millions of years. Even without such long-term speculation, the immediate reality of uplift is profound. Satellites tracking millimeter-scale changes can now watch as entire ridges swell and valleys deepen. The technology to measure this change brings with it a new understanding of Earth's capacity for sudden expression. Where once geologists might have said the Appalachians were static, they must now describe them as active, responsive, and unpredictable. This shift in perception ripples outward, reminding humanity that the planet is never still, even in the most familiar of landscapes. The red alert serves not just as a warning, but as an invitation to rethink humanity's relationship with the ground beneath its feet. The Appalachians rising is more than a geological curiosity. It is a reminder that stability is often an illusion, that even the oldest mountains can stir, and that the forces of Earth remain capable of reshaping the world in ways both subtle and profound. As research continues, the Appalachian uplift stands as one of the most fascinating and consequential developments in modern geological science, its implications stretching from the microscopic composition of rocks to the grand sweep of planetary dynamics. The sudden detection of massive uplift in the Appalachian Mountains did more than surprise scientists. It rewrote assumptions about what this region is capable of. For centuries, the Appalachians have stood as a monument to time's relentless power, their craggy ridges smoothed by erosion and their highest peaks dwarfed by younger, more volatile ranges. Yet beneath their surface, forces far older and more powerful than any human timeline have always been waiting. The red alert issued by the USGS forced an acknowledgement that the Appalachians are not dead mountains, but living structures still tied to the Earth's restless interior. With every new set of satellite readings, the extent of the uplift grew clearer, and so too did the realization that this event carried implications that stretched across geology, ecology, climate science, and human settlement. The layer of inquiry focused on scale. How much land was actually being lifted? Satellite data suggested that the phenomenon was not isolated to one ridgeline or valley, but spread across hundreds of miles, from central Pennsylvania down through Virginia and into North Carolina. The pattern was uneven, with some ridges climbing more rapidly than others, yet the overall movement was coherent. This indicated a force acting from deep below, rather than surface-level anomalies. The scale alone made it historic. In most cases, mountain uplift unfolds in increments so small that only millennia reveal the difference. For the Appalachians to be rising in increments detectable over a season meant something extraordinary was taking place. Understanding the possible causes became the next challenge. Seismologists deployed portable instruments across the region to capture tremors that might be associated with deep movement. These devices recorded a subtle hum of microseismic activity, the kind of low-level vibrations usually associated with mantle flow or the shifting of faults too deep to break the surface. Combined with gravity field measurements from orbiting satellites, the data painted a picture of material rising within the Earth, pressing upward against the overlying crust. The Appalachians, once thought to sit atop a geologically quiet section of continental plate, were now showing behavior that hinted at dynamic activity beneath. The potential involvement of mantle plumes was a topic of intense debate. Normally associated with volcanic regions, mantle plumes are upwellings of hot rock that can generate massive surface changes over long timescales. If such a plume was rising under the Appalachians, it would challenge long-standing geological models of the eastern United States. The region is thousands of miles from an active tectonic boundary, far from the zones where plates collide or spread apart. For a plume to be active here would imply a degree of complexity in Earth's interior that science has only begun to map. Some researchers propose that ancient scars in the lithosphere, remnants of when the Appalachians were first formed during continental collisions, might be reactivating. These weak zones could allow deep heat and pressure to find pathways upward, creating the observed uplift without producing the obvious volcanic signatures seen elsewhere. Beyond the mechanics, the ecological implications of uplift were profound. Mountain ecosystems are shaped by altitude, slope, and the flow of water, all of which are tied to elevation. As ridges rise and valleys adjust, plant and animal communities face shifts in their habitats. Species adapted to specific elevation zones, such as red spruce forests or the habitats of highland salamanders, could suddenly find themselves displaced. Rivers fed by mountain springs may carve new channels, altering floodplains and wetlands downstream. Even small changes in elevation can ripple outward into large changes in ecological distribution. And scientists were quick to begin modeling how Appalachian biodiversity might respond to the land itself moving beneath it. Water, always central to mountain systems, presented another dimension of concern. The Appalachians are a source of countless rivers that supply drinking water, irrigation, and hydroelectric power to millions. Uplift changes gradients, and gradients govern flow. If a ridge rises, a river's slope can steepen, speeding currents and increasing erosion downstream. Conversely, valleys tilting differently can create new flood risks. Reservoirs carefully engineered to balance inflows and outflows may no longer operate as intended if their catchments shift. In a region where communities depend on consistent water supplies, even minor shifts can carry far-reaching consequences. Hydrologists began reassessing maps, asking not whether rivers would change, but how quickly and in what ways. Communities in the Appalachian region also confronted the cultural shock of the announcement. For people whose families have lived in the same valleys for generations, the mountains are more than geology. They are identity. The land provides not only livelihood, but a sense of permanence. The red alert disrupted that sense, suggesting that permanence was illusory. The ground itself was changing, and with it the landscapes tied to memory and tradition. Storytellers and historians began to reflect on how local culture, rooted in the idea of enduring mountains, might adapt to the notion of living, shifting peaks. The symbolism of the mountains stirring after seeming eternities of stillness became a subject of both fascination and unease. Economically, the stakes are no less significant. The Appalachian region remains tied to resource extraction, from coal and natural gas to timber and stone. Uplift could alter access to these resources in unpredictable ways. Strata of coal once safely buried may move closer to the surface, tempting renewed interest in mining. At the same time, New fractures could render extraction unsafe, as gases or groundwater suddenly shift. Natural gas pipelines, which already crisscross the region, may find their buried roots stressed by movement, raising the specter of ruptures or leaks. Engineers tasked with maintaining these infrastructures face a landscape that may no longer conform to assumptions of geological stability. Tourism and outdoor recreation also entered the discussion. The Appalachians draw millions each year to hike, camp, and explore their famous trails, from the Smokies to the Blue Ridge. If uplift alters trail alignments, destabilizes slopes, or changes the availability of certain scenic overlooks, the character of these experiences could shift. National parks and local tourism economies depend on the appeal of a landscape shaped over eons. A landscape suddenly in flux presents new risks but also new wonders. Rising ridges may reveal vistas unseen in human memory, or expose rock formations long hidden. What this would mean for visitor safety and management, however, required urgent attention. Politically, the red alert stirred debates in state and federal halls. Some saw the event as a call to invest heavily in scientific monitoring, expanding networks of sensors and research centers to ensure early detection of further changes. Others focused on infrastructure resilience, arguing that roads, bridges, and power systems should be reviewed for vulnerabilities in light of possible continued uplift. Still others worried about the economic costs, questioning whether resources should be devoted to a geological phenomenon whose long-term trajectory remained uncertain. The conversation highlighted the tension between scientific curiosity, practical necessity, and fiscal limitation. Internationally, the Appalachian uplift drew attention as part of a broader pattern of unexpected geological activity worldwide. From unusual volcanic events in Iceland to rapid ice loss in Antarctica, Earth seemed to be entering a phase of heightened dynamism. The Appalachians, once considered a symbol of quiet stability, now joined this global narrative. Geologists in Europe, Asia, and South America studied the data, comparing it to their own mountain systems, seeking clues about whether uplift of this kind might signal a trend or remain a unique anomaly. The global scientific community recognized that the event underscored just how much remains unknown about Earth's deep interior. One of the most striking aspects of the Appalachian uplift is the way it challenges human perception of time. Normally, geological change is so slow that it requires imagination to grasp. Mountains rise and fall over millions of years, invisible on a human scale. But here was change happening within months, observable within a single lifetime. For scientists, this compressed timescale offered a rare opportunity. For ordinary citizens, it carried a sense of disorientation, as if the bedrock rules of the world had shifted. Philosophers and thinkers began to reflect on the lesson that even the most solid-seeming aspects of existence are subject to sudden transformation. The role of technology in detecting the uplift cannot be overstated. Without advanced satellite arrays capable of measuring shifts in Earth's surface down to millimeters, the event might have gone unnoticed until larger consequences forced recognition. The satellites, equipped with radar interferometry and precise geodetic instruments, provided a view of the Appalachians invisible to the naked eye. Their findings not only triggered the red alert, but also demonstrated the power of modern observation to reveal phenomena once hidden. As more satellites come online in the coming years, humanity may discover that the Earth is far more restless than previously thought, with regions long assumed stable in fact moving beneath us. Looking forward, researchers began discussing the possibility of predictive models for uplift. By combining satellite data, seismic readings, and computer simulations of mantle flow, they aimed to forecast how the Appalachians might evolve in coming years. Would the uplift accelerate, plateau, or reverse? Would it trigger secondary effects such as earthquakes or landslides? Could it represent the early stirrings of a new mountain-building phase? These questions remain unanswered, but the pursuit of answers has already reshaped research priorities. Universities across the country launched new programs in Appalachian geoscience, and funding agencies redirected grants toward understanding this singular event. Cultural responses also began to take form in art, literature, and music. The Appalachians have long inspired creativity, their ridges and hollows appearing in folk songs and poetry. With the news of uplift, artists found new metaphors in the rising mountains. Painters depicted ridgelines swelling toward the sky, musicians wrote ballads about the land stirring beneath their feet, and writers explored themes of resilience and transformation. The event provided not only scientific data, but also new imagery for the human imagination, linking geology to the timeless urge to make meaning from change. There is also the question of spiritual and philosophical interpretation. In many traditions, mountains are symbols of permanence and connection to the divine. The sight of the Appalachians rising again, even subtly, invites reinterpretation. For some, it is a reminder of creation still unfolding, the earth not finished but alive. For others, it is a humbling lesson in humanity's smallness against the backdrop of planetary processes. In churches, community gatherings, and informal conversations, people began to weave the event into their understanding of the world, finding in the uplift a call to humility, awe, or renewal. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on USGS Red Alert? Do you believe major geological events are imminent? We want to hear from you. Thank you for watching and see you next time.